Okay, so in example 2, I'm going to show you that actually just because we have a product, it doesn't mean that I'm going to apply the product rule, that I have other options, but it just depends on what the factors are. So I have f of t equals rad of t times a plus b times t, so I'm going to apply the rule. So I'm going to do this one using the product rule. So f prime of t would be derivative of the first, which remember that this is t to the 1/2, so it would be 1/2 becomes the new coefficient, and then the new exponent is 1 less than that, so that would be negative 1/2 times the second one plus the first one. Since I'm writing it as exponent, let me just write it as exponent. Times the derivative of the second one, derivative of a respect to t. It does not depend on t, so this is 0, and this will just simply be b. Remember, like if it was 3t, the derivative is 3. If it was 4t, it would be 4. So because it's bt, the derivative is simply b. I guess I could write this as root. Really, there is nothing else to do here, but maybe I can distribute the t's, but yeah, let's do that. So I have 1/2 of t to the negative 1/2 times a plus 1/2 b times t. This is t to the 1 plus negative 1/2, it will be 1/2 plus b t 1/2. These two happen to be like terms, and this is something that I was just thinking about, that maybe that's the case. So I'm just going to combine these two like terms. 1/2 t to the negative 1/2 a plus 3/2 b t to the 1/2. And this will be one way of writing the answer. You may see in, if this was multiple choice, I could maybe factor out a t to the 1/2, to the negative 1/2. But, it depends. For this particular problem, I could just leave it like that. So the other way of doing it is just using the power rule that we have learned before. That is a lot faster. Let me just rewrite f of t. F of t will be a rad t plus b, and in this case, well, let me just write it as exponent. A t to the 1/2, and then this would be t to the 3/2. And then I'm just taking the derivative using the power rule and the sum rule. So f prime of t will be 1/2 a t to the negative 1/2 plus the derivative of this, which will be 3/2 of b t to the 1/2, which is exactly what you got over here. Isn't that nice? But in here there's a lot of algebraic manipulation. In here not so much, only at the beginning. So I would recommend to do it this way rather than this way, in cases where we only have powers, we only have t to some exponent, so that's a lot faster than doing it this way. So we just have to get smart about how we're looking at an exercise and to see what will be the quickest way. I like this example because it's kind of giving you the introduction for something that we are going to see later on. In here I have f of x defined as rad of x times some function g of x. You don't know what this look like. This could be linear or rational or polynomial. It could be anything you want. But let's try to find the derivative of the value of 4, giving you these hints. So let's just apply the formula. Remember that when you are asked for the derivative at some x value, you could use, and we did it before, you can use the formal definition of derivative using the limit as h approaches 0 of blah 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 blah, f of 4 plus h and so on. But applying these rules, you first have to apply the rule to the function and then evaluate 4. Please don't evaluate and then take the derivative, because if you evaluate, you're going to get a constant, and the derivative of a constant is 0. So that's a big mistake. So just find please f prime and then evaluate. So f prime of x will be the derivative of the first one, which will be, if this is x to the 1/2, it will be 1/2 of x to the negative 1/2 times gx plus x to the 1/2, that's the first one, times g prime of x. Okay, so this is what f prime of x is. Now let's see what we have for information. If I'm asked for f prime of 4, I know how much is x, so these two are known, but then I will have to know what is g of 4 and what is g prime of 4, which is actually the given information on the problem. So I know this one and I know that one, so I can definitely find f prime of 4, even though I don't know what g looks like. I don't care. Okay, so I have 1/2 of 4 to the negative 1/2 times g of 4 plus 4 to the 1/2 times g prime of 4. So let's just replace. So when I replace, just be careful whenever you have a negative exponent. This is just the reciprocal of this quantity. The 2's are gone. 1/2 plus 6, 6.5, or 13/2. This slide here summarizes all the rules that we've learned so far. Derivative of a constant is 0. Derivative of a power, you know how that works. Derivative of e to the x is itself. The derivative of a constant times a function is just a constant times the derivative of that function. Derivative of a sum is sum of the derivatives. Derivative of a difference of the derivatives. Derivative of a product, we have to do a lot more work than that, and the same as with the quotient. So again, to reiterate the fact that whenever we see a quotient, we don't always have to do the quotient rule. The same with the product. So I notice in here that although it says a quotient, this is a power of x, this is another power of x, divided by a power of x. So definitely the way to go will be using the power rule. So let me just set it up for that. I have to distribute the x. So I have 3x plus 2. This is x to the 1/2 minus 1. That will be x to the negative 1/2. And then I just apply the rule. F prime of x will be 3. Then this will be the new coefficient times 2 will be negative 1. And just write minus x, and the new exponent is 1 less than this one, so negative 1/2 minus 1 minus 3/2.